Hello friends, let's review what we've learned so far about plate tectonics and convection currents in the mantle. So what we know about plate tectonics today started with this guy right here, Alfred Wegener. He was a scientist who developed what's called the continental drift theory. He noticed a lot of evidence on Earth, some being that similar fossils were found in places that were completely far away from each other. He found, he noticed that a lot of the continents look like they kind of fit together like puzzle pieces, and also that mountain chains in places that were thousands of miles away from each other were actually the same age and the same kind of rock, so kind of like they were matching. He also saw that there were glacier deposits and evidence of glaciers in places that weren't anywhere close to each other and were too hot to support that. Notice, the tip of South America, the tip of Africa, all places that were currently, the climate didn't support it. And so he came up with this idea that the continents themselves have drifted over time. And at one point they were all together. Well, he didn't exactly know how to explain how that happened, but he used his evidence to say it must have happened at some point. And so he wasn't really well received until more evidence came to light, and he was kind of proven right a little bit with the development of what's called plate tectonic theory. And in plate tectonic theory, we scientists have said that it's not the continents themselves moving, but that there are plates. The continents rest on tectonic plates that move based on activity below the plates within the Earth, which we'll talk about in just a minute. But some of the evidence to support plate tectonic theory was that, oceans can be mapped now. The bottoms of the oceans can be mapped, so we can see plate boundaries. Earthquakes have been mapped over the century, and you start to see patterns of earthquake locations. And you can also start to see patterns of volcanoes and where volcanoes have occurred on Earth. And so all of that led scientists to develop the plate tectonic theory, which is the plates. The Earth is divided into tectonic plates below the oceans and below continents. And the plates can sometimes move towards each other, move away from each other, or slide past each other and create different crustal features. And the thing that Alfred Wegener was missing in continental drift theory was the how. And the plate tectonic theory came up with how, and the how was based on how the Earth is structured. So you have the crust and the mantle and the core is extremely hot, which provides our heat source for our mechanism for plate tectonic movement. Within the crust and the mantle, you have two different parts. The lithosphere, which contains all of the crust of the Earth, including the crust underneath the ocean and any land above the ocean. So the lithosphere is that plus the upper mantle, and that contains the tectonic plates. Those sit on top of what's known as the asthenosphere here, which is the part of the lower mantle, where rock is so hot that it behaves like a liquid, like a plastic. And what scientists have theorized is that this part of the Earth's crust, because it behaves like a fluid, it also can go through convection currents. We've learned so far convection currents happen. It's a cycle that happens when there's a temperature difference. Well, within the mantle, within the asthenosphere, you have superheated rock heating up and becoming less dense, moving towards the lithosphere where the plates are, and then cooling down when it becomes more, and then becoming more dense, and continuing that cycle because the Earth's core is heating it up. And because of that motion, it's moving whatever's on top of it, which in our case happens to be tectonic plates and the continents and the oceans. And so this was what continental drift theory was missing, was the how. And this is the how. This is how plates move and how landforms are created and different crustal features like earthquakes happen. It's all because of convection currents in the mantle with the heat source of the core. That's about all we learned in level 1 so far. So if you have any questions, make sure you ask your teachers, go back through your DIYs, look through your notes, use any of your resources to help you. If you have questions, let us know. See you later, guys.